Okay. Hands up. What's the first thing I'm going to do? Hands up. What's the first thing I'm going to do? Hands up. What am I going to do first? There we go. Y'all thinking with me. Does anybody get to watch? Let's go, Lexi.
I'm the second grader.
So Lexi, in her head, went straight to Danica's chart and said, I have a function for f. F is concave down whenever f double prime is negative. Since I don't have a graph, I need a sign chart. I need a sign chart as this. Please show me your hands if you knew that before she said it. 2.3 for Lexi. You will talk more about it. Cool. So, f prime. It's another product rule problem. Getting better at doing this with less writing. I take the second function, which is e to the x. I multiply by the derivative of the first, which would be 2. I say plus the first function. The derivative of e to the something is always e to the same something multiplied by derivative of the something. So that's my first derivative. 2 e to the x plus 2x e to the x. Questions? Let's stop that. Please. Say again.
Can you factor that right there?
Oh, hold on. As I walk to David and pay him, please remember this thought. My experience has been that when we need to analyze something, factored form is best. Like factored form helps us to find the zeros, it helps us to do a sign chart, helps us to find limits. When I need to find derivatives, I don't factor unless it's already factored. So because it's as is, I just leave it. It seems like I find it easier. So there's nothing wrong with factoring. I just think it's easier to leave it for now. So now I need to find f double prime. So this is just a multiplying constant, so I just write it down. I already did it. The derivative of e to the x is just e to the x. Do you need me to do anything more there? I'll show more detail if you need it. Cool. Plus, this is the product rule again. But wait a minute. I just found that. Just found that derivative. It's right here. Going to write that down. If you need me to talk through that, wait. Cool. What's the next thing I'm going to do? Hands up. Hands up. What's the next thing I will do? Sam had too late of a night. It's okay. Happens to all of us. Let's go, Ilana. Yeah, now we want to make the sign chart, but going back to David, 3 for Ilana. I do want whatever I'm sign charting to be in factored form because I'm analyzing, and factored form makes analysis easier. And what else can I factor out, Allison? 2. So stay with me. So I'm going to pull out a 2 and an e to the x. So what goes here, Allison?
1.
Perfect. Then here's the plus. What goes here? 1 again. And here's the plus. Nice. 3 more for Allison. Okay, anyone need me to give more detail? Discuss more, anything? Please.
So I just kind of need to talk to you. So why is the derivative of 2e to the x 2e to the x?
No worries. So let's write it over here. So I have d of 2e to the x over dx. If you don't know, just say I don't know, but do you remember what rule I would use first?
Is it multiplying constant?
Huh? So what would I write here, Mike?
So it'd be 2 and then e to the x.
Oh, d of.
Or d of e to the x.
You okay with that?
dx, yeah.
Okay. So now we use the e rule. E rule says derivative of e to the something is e to the something multiplied by d over dx of that something.
Yeah.
That's equal to 1. That's how I end up with 2e to the x.
So it's just the same.
Uh-huh. That is your question?
Yeah.
3 points. There we go. Okay, you all need to memorize something. Last year you learned the y. This year we just need it memorized. It does not matter what x you pick. E raised to that x will be positive. Never 0, never negative. If you feel like you will be able to remember better by having me show you some examples of why that's true, let's go like this and I'll show some examples. Everyone seems content to simply, oh, please.
Wait, so like, using e to any power is positive?
Yeah, so like give me a number, I don't care, Allison.
Okay, 5.
So E is about 2.7. So are you 100% sure that 2.7 to the 5th is positive?
Yes.
Good.
Okay.
Give me a negative number.
-3.
Any base to any negative exponent is simply 1 over same base to the positive of that exponent. So that becomes 1 over e cubed. But e is about 2.7. So are you comfortable that 2.7 cubed is positive? Yeah, 1 over positive is still positive. So it doesn't matter which number I plug in, positive or negative, the result's going to be, feel good about that? The only other possibility is this. Is that okay? Good point. So we're sign charting. We've got factors, that always helps. This factor won't equal 0. So we just need to find when this factor equals 0. I don't even want to ask you because it's too easy. So x f double prime negative 2. Question? Now we just test. So we plug in, say, negative 3. This is still positive. This is now negative. So multiply together, positive times negative is negative. Check negative 1. This is still positive. This is now positive. Please show me on your hand A, B, C, D, E. Show me. What is the correct answer? Show like this so everyone can't see. A, B, C, D, or E. A, B, C, D, E. This means I really feel clueless. I've got to find time to stay after school. So, and the sooner the better since the test is fast approaching.
We need to do
The test, keep losing class time, so I'm going to have the test be again online. And I will have it ready before the Thanksgiving break, and the due date will probably be very quickly after the break. So it's not like you have to do it over the break, but the break just kind of spans the due dates. So if you're doing this for yourself too, we need the correct answer is A. Question. Oh, bell ring in 90 seconds, so.